Assalamualaikum, my name is Muhammad Arif Saukan bin Ahmad Ajizi.
My name is Fendi Azwar bin Sabarai.
Assalamualaikum, my name is Nurul Isya binti Zawzamir. Assalamualaikum, my name is Nur Sumail Alisha binti Mawar Hafiz.
Hi everyone, today we are going to explore the concept of compound interest. Compound interest is essentially interest earned on both the initial principal and the accumulated interest from previous period. That means your money grow exponentially rather than linearly. Interest can be compounded on variety of frequency such as daily, monthly, annually, and also quarterly.
These are the formula for compound interest. S equals P bracket 1 plus I bracket power of N. To find the interest amount, I equals to S minus P. Lowercase I means periodic interest rate. Lowercase n means number of interest period. Capital I means interest amount. P, original principal. S, maturity value. K, nominal interest rate. Last but not least, M is frequency. Without further ado, let's jump right into the problem statement. Question 1. Ali invests 1,000 ringgit in an account with an annual interest rate of 2.5% compounded monthly. After 6 years, Ali withdrew 200 ringgit. After another 6 months, the interest rate increased to 4% per year compounded monthly. Calculate the accumulated amount at the end of 6 years. A. Find the accumulated amount S at the end of the investment period. First of all, to answer this question, you must identify the information given. P, the original principal, is 1,000 ringgit. T, year, is 6 years. K, the nominal interest rate, is 0.025. M, the frequency, is 12. N, number of interest period, is 72. I, the periodic interest rate, is 0.025 divided by 12. I am going to use the formula S equals to P bracket 1 plus I bracket power of N. S equals to 1,000 bracket 1 plus 0.025 divided by 12 bracket power of 72. Thus, S equals to 1,161 ringgit and 65 cents. B. Calculate the amount of interest, I. In this question, I am going to use the formula I equals to S minus P. Since I already calculate the value of S and the P is given already, I can straight away use them. Therefore, 1,161 ringgit and 65 cents minus 1,000 equals to 161 ringgit and 65 cents for the interest amount.
C. Calculate the accumulated amount after a withdrawal. So based on the question, Ali withdraw 200 ringgit. So we use formula I equals to S minus P. 1,161 ringgit and 65 cent minus with 200 ringgit. So the answer is 961 ringgit and 65 cent. The last one, D. Calculate the accumulated amount after the interest rate change. So based on the question, the interest rate increased to 4% per year, compounded monthly. So the first step, we can separate the new information. P is 961 ringgit and 65 cent. T is 0.5 years because the question only asks for 6 months. K is 0.04. M is 12. N is 6, which is 12 multiplied by 0.5. I is 0.04 divided by 12. So we use formula S equal to P bracket 1 plus I bracket power of N. 961 ringgit and 65 cent bracket 1 plus 0.04 divided by 12 bracket power of 6. So the answer is 981 ringgit and 4 cents.
Introduction to annuity. First, an annuity is a financial product of arrangement where a series of payments are made or received at regular interval over a specific period. Second, annuity are often used for retirement planning or to provide a steady income stream. Lastly, they can be structured in various ways depending on the purpose and need of the individual.
Annuity formula. In this part, we should know what is S, A, R, small capital N and small capital I stand for. So what is S? S is a future value, or we know it as total saving or accumulated amount of unpaid payment. Next is A. A is a present value of annuity, or known as the original value, invest or loan. The third one is R. R is periodic payment, and small capital N stand for number of interest period. Last but not least, small capital I stand for interest rate. So now there are two formulas to find future value and two formulas to find present value. So to find future value, we need to use this formula, which is S equal to R bracket in bracket 1 plus I power of N minus 1 divided by I. The second formula, which is to find interest amount. The formula is I equal to R bracket N plus minus A. Next, to find present value of annuity, the formula is A equal for bracket 1 minus bracket 1 plus I power of negative N and divide to I. The second formula is to find interest amount, which is I equal to S minus R bracket N.
Question 2. Saiful buy car which is Honda Civic Type R. He paid 399,900 ringgit with 10% down payment. The balance is to be paid in equal monthly installment for 7 years. The first installment is due 1 month after the date of purchase and the interest rate is 3% compounded monthly. A. Calculate the monthly payment. First, we must identify the information. A is 359,910 after deduct the 10% down payment. M is 12, T is 7 years, K is 0.03. After we put all the information in present value formula, we get R is 4,755 and 60 cents.
For question B, the question is to find the interest amount that Saiful need to pay. The suitable formula to solve this question is 1 equal R bracket N minus A. Our R is 4,755 ringgit, 0.60 cent. Our N is 84. Meanwhile, our A is 359,910. After we substitute the information given into the formula, I equal to 35,916 ringgit, 0.40 cent.
C. If Saiful failed to make 7 monthly payment, how much should he pay on the 8 monthly payment to settle all the outstanding area? So we use the present value formula. A equal 4,755.60 cent bracket 1 minus in bracket 1 plus 0.03 to be power minus 36 divide with 0.03 over 12. So we get new R is 163,528.27 cents.
For question D, the question is asked to find amount that needs to be paid if Saiful decides to settle the loan in full payment. The suitable formula to solve this question is S equal R bracket in bracket 1 plus I power by N minus by 1 divided again by I. Our R is 4,755 ringgit 60 cent. Our I is 0.03 divided by 12 and our N is 8. So S equal to 4,755 ringgit 0.60 cent bracket in bracket 1 plus 0.03 divided by 12 power by 8 minus 1 and divide into our I again, which is 0.03 divided by 12. Our answer is 38,379 ringgit, 0.36 cents.